All right, so this is our can and bottle separation system. We have clear plastics right here, colored plastics, and a can. We have two separate conveyors. This top one is gonna be separating using an optical sensor. We have it set up so that if it detects color, which would be the cans and the colored plastic bottles, they'll just run through and fall into the second conveyor. If it does not detect any color, it'll identify it as a clear plastic, where we'll have to manually remove it because we do not have a mechanism to actually autonomously remove the bottles and cans. So once we have this removed, it should just be colored plastics and cans on this bottom. We have a distance sensor right here. The distance sensor is set up so that if cans are greater than 3 inches away from the sensor, then it detects can. When it's crushed this much, it is. And we will manually remove the can once again because we do not have that mechanism to remove it. If it's a bottle, it'll be less than 2 inches away from the sensor. So that means we'll just have it run through rather than tell us to manually remove it. Both of those things should pop up on this brain screen right here, and we'll test it. So we're gonna start the whole system using this black start button. This will activate both conveyor systems. And then we'll put our bottles and cans in manually just because we don't have our funnel able to go on top of this. The center of gravity is just way off and the weight is too much. So that was telling me to remove the plastic bottle, to get rid of that first since it didn't detect any color. Let's see if this one detects color. It should, but it's not printing on the brain screen. Same thing with a can. It'll run through, both colors are detected. We'll let it fall into the second one where we have bottle detected. We're just gonna let that run through. As for cans, we have our can, we have our can detected, there we go. And we'll manually remove that off. And that is our separation system for crushed bottles and cans. Thank you. All right, so this is our crusher system. It's ran off a pneumatic cylinder. We have a unique crusher cup in here. You can't lift it right now because it's activated, but there's 3 different fittings in here. We have a fitting for bottles, all cola bottles. We have a fitting for Gatorade bottles. We have a fitting for 12-ounce aluminum soda cans.
It's called air pressure. I could do it other ways. Not really, but go ahead.
That's unfortunate. All right, now that we've demonstrated everything that our can and bottle crusher and separator can actually do as of the deadline, I'd like to go over a few things that I would have liked to see it do that it was initially designed to do. So one of those big things that disappointed me was not being able to get our funnel system to cooperate with our crusher here. So now I want to demonstrate how our initial intake funnel system, this top piece, will cooperate with this bottom piece, which is the materials box. They're 2 separate components, and how that would all cooperate with our crusher itself. So let's say you have a grocery bag full of bottles and cans, right? You get to dump them all in at once. Just slide that in there. Boom. The weight of the other materials will flatten the first materials down into a horizontal position. So the initial design for our intake funnel, materials box, and crusher box was placed in this order as seen in the CAD model. There was a couple issues that weren't resolved in time that led to us not even be able to use either of these components and not implement the whole stage 1 part of the system into the final system by the deadline. One of those major problems where there was no way for us to stabilize that box efficiently without rebuilding a whole nother box, and it's just something we should have thought about beforehand, because that's a very powerful pneumatic cylinder, and this is a very lightweight box. So if we were to add a back plate, which there is supposed to be one there, if it's on its side, of course, we would have that pneumatic cylinder come down, it would push that back plate out, and it would rip like this whole part of the box off. It's too powerful. Number two is once that hits the back plate, the box is going to shoot that way. We have a force going this way. It's going to want to repel that way. So there's no good way to stabilize the box in time. Something we should have thought through in our design process. Another big issue with this is there was no way to ensure that only one bottle or can entered this crusher box at a time, because they are all being stacked in this materials box, right? We don't know, or we can't guarantee that only one's gonna fall in at a time, because as soon as one gets pushed, another's gonna want to come down, and that pneumatic rod needs to be going back. It's gonna create jamming, a lot of problems. So I want to demonstrate what it would be if we were able to do this effectively. We have our bottle being placed in there. Very nice. Very nice. As you can see, that crusher cup is big enough to where even if this is at an angle, it's going to grasp it as it goes down, because we have those rounded edges in 3 different fittings. This will meet with the cola bottle fitting, be crushed, and there's supposed to be a little slit right here. And the idea was to have it fall onto this top conveyor, have the structure built for that hovers over this, but it just wasn't able to get done in time. So there's a quick explanation of why we couldn't enter this whole stage 1 process of the whole project into stage 2 process. So that's the initial intake, materials box, and crusher, why we couldn't put it above this and let it run all as one. In the future, my team hopes to spend less time worrying about the problems and more time understanding the problems. I think my team spent a lot of time on the design process without actually realizing the scale of how everything is put together. I don't think any of us have real building experience, so it's a really good opportunity for us to finally get our hands on the project and build it ourselves, rather than just create blueprints for other people to build. So it's really nice. I'm able to see now that these conveyors are too small. We should have expanded that. This is not a great structure. This should have been designed differently so that it could actually stay still. And these two actually were pretty nice. I'm really proud of those. I'm really proud of everything. It was just a big learning curve. Our coding didn't go great. We were able to get the conveyors to run, but we didn't have enough time to test after building. We were really cutting it close, and so when we went to test it, we found out, okay, it runs. That's all we have time for, and the whole user interaction was kind of missing. But the whole coding issues gave us a better idea of how to code more complex systems, and it was good practice, the whole project.